What's going on, guys? Welcome back to another Swift video. In today's video, we're going to be learning about the VIPER architecture pattern in iOS apps. So this is arguably one of the more complicated patterns, but a lot of you guys have requested it. So here is a diagram of basically this pattern in a nutshell, and it's not the simplest. So we've got this cool acronym VIPER, which is I guess why it makes it cool. So it's a view, interactor, presenter, entity, and routing. We're going to take a look at what each of these things do, why it's useful to use this pattern, and then we're also going to implement an actual solution, which is going to have an API call involved to go and get data. So you'll see a real world application of this instead of just a bunch of theory, which in my opinion can be kind of useless sometimes. So if that all sounds good, make sure you start by absolutely destroying that like button down below. It helps out way more than you guys probably can imagine. Subscribe to the channel if you're new and into iOS. Let's get into VIPER in iOS. All right, we're going to go ahead and get started by opening up Xcode and creating a new project here. We're going to stick with the app template under iOS. Let's go ahead and give this project a name of VIPER. Make sure your language is set to Swift, your lifecycle UI kit, and your interface's storyboard. Go ahead and continue. I'm going to go ahead and save this onto my desktop, and we're going to expand our Xcode window before we get started. So VIPER, like I mentioned, is an architecture pattern that has a view, interactor, presenter, entity, and routing. So what I'm going to go ahead and do is I'm going to create a new file for each of those things, and then we're going to put each of those things in their respective file and talk about them so we actually understand what the heck is going on. So let me go ahead and create a folder called VIPER, and bear with me while I create 5 files. So first we have something which will be the view, which is actually kind of a bad term for it, and I'll explain why momentarily. The next part of the acronym is the interactor. All right, the next one in VIPER is the presenter, so new file, new Swift file, and we're just doing new Swift files. We'll fill these in as we go along based on whatever class we need, but we'll just start with an empty file for the sake of doing it from scratch. The next thing, which is the simplest part of this whole thing, which is the entity, which is basically just a model. And the last thing, which is the, if I can go to new file, the router. And the router is common in other patterns as well. It's basically the thing that helps you navigate and route throughout your application. So let's go ahead, new file, and add in a router. All right, so let's go ahead and talk about each of these one by one, but before I do so, one other thing that we want to go ahead and do is I'm going to right click on the main.storyboard, and we're going to hit delete and move to trash. We're not going to use the storyboard, we'll set this up programmatically. Let's also go down into the info.plist, and from in here, you want to get rid of the main storyboard file reference, and then if you open up application scene manifest, and if you keep going down into this, there's one more place where it references main.storyboard, since we'll do all of this programmatically. So go ahead and highlight it, hit backspace, and you'll be in good shape. So cool, let's talk about each of these. So the view, I'm going to put comments here as we talk about them before building them out, is responsible for, you guessed it, the user interface. Now the one confusing thing about the term view here is that you can have a view controller be the view as a part of this architecture. But we do want a protocol that's going to reference, outline what this view controller object should have on it. And the important thing on here is that we need a reference in the view to the presenter. So that's the view in a nutshell, and when we build it out, you'll see that in practice. The next thing is this interactor thing. So this is an object that we also need a protocol for, and the interactor should only have a reference to presenter. So I'll say ref to presenter. The interactor's job is to more or less go and maybe get data or perform some type of interaction, and then when it has that interaction completed, go ahead and hand it to the presenter, and then the presenter will take care of what to do with it. So in here, we can also make an API call. So I just grabbed a random API endpoint to get a list of some data back, so I've just pasted that in there. So the presenter is actually the glue that ties everything together. So of course, it's an object. We'll want a protocol for this as well. And the presenter has references to three things. So this has a reference to the interactor. It also has a reference to the router. And then it, of course, also has a reference to the view itself, because the presenter needs to present the view and tell the view what the heck to do. So moving along, the entity piece, like I said, is the simplest. This is just going to be the model. It doesn't have a reference to anything else. It's basically all the entities throughout our application, otherwise known as models. Honestly, I think they chose the term entity because it's a cooler acronym to say VIPER, and an M doesn't work out very well there. But lastly, router. So the concept in VIPER is there are different modules in your application, and a router can route within its own module. So the best way that I like to explain this is, let's say you have an app with 5 tabs. Each tab is perhaps a module. So we're just going to go ahead and say here is a router. It's going to be, let me just say object, and it doesn't have a reference to anything else. It only has, in our case, one presenter, but it is the entry point for our module, and this is where the VIPER architecture starts. So this is how we're going to get the entrance view controller in our scene delegate momentarily. So let's go ahead and start building all of these out. So I'm going to start with the router, since it's how we set up our entire pattern. So we're going to have a protocol for each of these types of objects. So this is going to be a router. And I can also go ahead and call this maybe any router, which is a common naming convention for protocols. So what we're going to have in here is simply a static function, and this is going to be, you can call it create or even start, both are acceptable. And what this is going to do is this will return to you any router, just like that. And basically come down here and we can create a implementation of this. So I'm going to go ahead and say class, and we'll go ahead and say user router. The reason I said user here is because our API endpoint is actually going to return a list of users. So we'll say user router is of type any router, and you'll see an error pop up here in a hot second, just like that, because we need to conform to this guy. So we'll go ahead and add in fix just like that. And then in here, we want to actually go ahead and create all of our components of VIPER and return it. So since we only have a router at the moment, let's just go ahead and create this. We'll say it's a user router, and then I can return a router just like that. So that being done and said, let's go ahead and create the other objects, and we're going to want to assign the other VIP inside of here. So view, interactor, and presenter. But let's go ahead and create them before we try to use them. So let's do entity, which is pretty simple. So entity is basically going to be nothing more than a user struct. It's going to be codable, and we're just going to have a single property in here called name of type string, if I can spell things correctly today. So there is our user. It's our entity, nothing too fancy going on in there. All right, cool, presenter. So a presenter is once again going to have a protocol. This is going to be any presenter, and we're going to have a concrete implementation of it. So we can say have a class, and this can be user presenter, and it's going to conform to any presenter, just like that. Now, what is any presenter going to have on it? So first and foremost, it needs to have a reference to an interactor, the router, and the view. So the way we can do that is by saying, first and foremost, it'll have a router of type any router, and this is going to be a gettable, and I guess settable as well, and it'll be optional. The next thing that we're going to want on here is a interactor, and we haven't created this yet, but you get the idea. We're going to create an any interactor, if I can spell it, there we go. And then finally, we're going to have another thing on here, which will be a view, which is going to be any view. And once more, it's going to be optional and get set. And before this continues to yell at me, let me go ahead and just stub out those protocols here. So here's going to be a protocol for any interactor, just like that. We're going to have a concrete implementation in here as well. So user interactor. And I promise once we tie all of this together, it's easier to understand. Right now, we're just creating a bunch of objects and protocols. And honestly, that's one of the reasons that this architecture pattern is a little difficult for some folks to understand, because it does have a lot of different components. So this one is a view. So we're going to say this is a protocol for any view just like that. And we'll create one concrete implementation here. We'll just call it a user view controller of type UI view controller. Autocomplete is not cooperating because we need to import, I should say, UI kit. So we'll go ahead and inherit from UI view controller and make this an any view. So let's go back to where we were. So we were back, I believe, in the presenter. So in here, we're going to have a any view. We're going to have a any interactor. So let's go ahead and hit Command B, see if those autocompletes go away. All right, those errors have gone away. Let's ignore this for a moment. So any presenter, what else does this presenter need to do? So a presenter will also need some functions on it because if you recall, our interactor will hold a reference to our presenter as we put in our comments here. So our interactor needs to tell the presenter, hey, some interaction just occurred. So we're gonna have a single function on here. And what we can go ahead and say is interactor did fetch, we can say users, and we can say this has a with result, and the result is going to be a result. In the success case, we should have an array of users back, and in the failure case, perhaps an error, just like that. And that's basically all we need. So now we'll hit this little error down here, and we'll hit fix to stub out all the stuff that we want. And Xcode didn't do its job, shocker, so we'll copy and paste that function as well since we're gonna want it. And let's see, we shouldn't have any more errors in here. This guy should go away. Awesome, looking great. And now what we can do is move on to the next object, which is the interactor. So the interactor, like we said, should have a reference to our presenter. So we're going to say var presenter in the protocol will be any presenter. It's going to once again be optional, get set, just like that. Now our interactor also needs to have some contract in terms of what functions we can call on it. So we're going to go ahead and say get. We'll say get users and no completion handler, because the idea here is the interactor will inform the presenter once it's ready. So instead of having a callback, just go ahead and make it take no parameters. So we'll go ahead and add that, and also add in that get users function here, which we'll implement momentarily. And that takes care of our interactor. Finally, we'll come into our view, and our view should have a reference to our presenter. So we're going to go ahead and say presenter is any presenter. All right. And on the view, we also want two different functions. You can do it in one as well, but we can go ahead and say perhaps update with users will be a collection of users, which is our entities. Or we can also say update, and we can say update with error. And this can go ahead and be a string, which whatever error that we want to show on our view, in our view controller. So that is the bare bones of the pattern. Let's go ahead and hook this up even more so we can actually start seeing, this in action. So let's go ahead and stub these out here. Let's stub that out. We'll also want to go ahead and override some stuff. So I'll say view did load. Since it's a pretty basic view controller, nothing too fancy going on here, we'll say super view did load. Now, for our purposes, what we're going to do in here is we're just going to have a table view that's going to show a list of users' names once we fetch it. So I'll also go ahead and create a table on here. So we'll say table view is of type UI table view, and we're going to create this with the anonymous closure pattern. This has nothing to do with VIPER. This is just creating a very, very basic vanilla table view. If you're not familiar with table views, take a look at my other videos on it, and maybe VIPER isn't the best thing to start off with. So we'll just come into here and register a vanilla cell. I'm not going to do anything too crazy. And we'll also go ahead and by default, we're going to say the table is hidden, and we're going to say true. And the reason we're going to do that is because we might not want to show the table in case, an error does occur. We'll go ahead and assign the delegate and data source of the table after we've added it to the view hierarchy with add subview, and then we'll want to go ahead and conform to the relevant delegate and protocols for the data source. So here is the data source, and now it's going to yell at me to bring in those required functions. So I'm going to do that down here. We're going to go ahead and say number, number of rows, this one right here, I believe. That's number of sections, number of rows. Now let's just return 0 for a moment, self row at index path. And let's just go ahead and hard code this so we can get back to the VIPER stuff. And we'll come back to this in a moment. So all right, we've got our VIPER pieces here. Let's go ahead and delete some of this other stuff that Xcode gave us. So it gave us a view controller by default. We already created our own user view controller, so we can trash this guy. We don't need that anymore. We do want to go back to our router though, because in here we left this comment that we need to set up our actual view interactor and presenter. So let's go ahead and say our view is going to be a any view, and we're going to go ahead and say this is a user view controller. Just like that, pretty simple. And let's see, what else do we want on here? So that is our view, and if we go into any view, well actually before we even assign more stuff on here, what we should probably do is let's go ahead and create the other stuff as well. So we'll say the presenter is going to be any presenter, and this is going to be a user presenter, keeping with our naming convention. And lastly here we want an interactor, which will be an any interactor, and we're going to actually go ahead and use the correct thing. And actually go ahead and say this is a user interactor. All right, so looking pretty good. What we want to do next is we want to assign these pieces on one another. So what I mean by that is if you go to any view, you recall that it needs to have a reference to the presenter. So here I can say view.presenter is the presenter up above. And let's see, this is going to yell at me. Why it's going to yell at me? Cannot assign to property view is a let constant duh. So we'll need to go ahead and make this a var, and a var like that. And the next thing we want to assign is the stuff on the interactor. So the interactor just has a reference to the presenter. Looking good. And then the presenter has a reference to basically everything. So router, it'll have a reference to router. Keep in mind we defined router right up here. And the next thing the presenter wants is a reference to the view. So view is view. And presenter has a reference to the interactor as well. So pretty darn simple. Let's see what else we want on here. We also want the router to have a reference to the view. So what I can actually go ahead and do here is I can actually say this any router has a view, which should be any view and a UI view controller. And the reason we want this here, let's go ahead and import UI kit, is because this is how we're going to tell our app delegate what the entry point of our actual application is. So it's important that we have that on here. So let's go ahead and just drop that in like so. One way that's cleaner that you can assign this is go ahead and type alias this to entry point. And here we can say the view is entry point optional. You can even call this like entry. And now on here, you can go ahead and say there is going to be an entry just like that. It's optional, so we don't have to give a default value. But here what we can go ahead and say is we can say router dot entry can be our view. And we can also say view as entry point, and it'll downcast it to the appropriate type. So now we can actually probably start seeing this stuff on the screen. So let's hook it up in our scene delegate. So in this first function here, this is where you can actually hook up the first view controller of your application. I'm going to go ahead and create a router. So we're going to go ahead and say router is going to be our end user router, and there should be a function off of here called start, which will give us a router reference. We can even say this is our user router, just like that. And then we want to get the actual controller out of it. So we'll say initial VC will be our user router dot entry, looking pretty good. And then we want to basically set it up with our window. So this up here turns into window scene. This is pretty similar to if you wanted to do this stuff programmatically. And here we would need to actually create a window. So I'm going to say window equals a UI window. We're going to go ahead and create this with a window scene, which is the thing up above. Now on this window, we want to actually set a root view controller, which will be our initial VC. We want to say window make key and visible. And before we do that, or we can even do it after, it doesn't really matter. We just want to keep a reference to it. So we'll say self.window equals window. So that all said and done, go ahead and hit Command B, and let's see if we have any build errors. Hopefully we do not. I'm also going to go ahead and change our simulator to a 12 Pro Max. And actually, before we even run it, let's go ahead and do some more cleanup here. So we're going to go ahead and come to our view. Now our view currently doesn't even have a background color. So let me go ahead and add maybe a background color so we can see that stuff is actually appearing. And then after that, we'll actually hook up our interactor to fetch a number of users. I'm also going to override view did layout subviews. We'll say super view did layout subviews, and here we'll say table view dot frame is view dot bounds, just like that. So go ahead and hit Command R to build and run, and let's see if we're seeing our blue screen. Hopefully we are. If not, we'll debug it together. So it's still white, which implies that it's still launching, so just bear with the simulator, like it loves to be slow every time I do a video, but there is our blue screen, look at that. So cool, we've got our router being created, and it's handing the view, aka the primary controller, to our window, so that's looking good. What else do we want? So now on this view, we can have the view say, you know, go ahead and get me the data. However, it's not really the view's job to do that. So what we could go ahead and do is do that in the router. But instead of even doing that, the other thing that we could do is in the presenter, it can go ahead and reach out to go and start getting a list of users. So the presenter has a reference to the interactor. So one thing we could do is we could say in the initializer here, we can say interactor. And on the interactor, we need a call to get users, which we have already. So we can do that as soon as we instantiate the presenter here. So let's go into this get users implementation, and let's actually implement fetching users. So like I mentioned, I've got this URL here, which gives us a collection of users back, just some JSON. So let's go ahead and create a pretty basic API call here. So I'll just go ahead and say a task is going to equal a URL session dot shared, and we're going to do a data task, and we want to do it with a URL and a completion handler. Now let's go ahead and create the URL up above. I'll just do that up here. So let's go ahead and say guard let URL is a URL with a string. I'm just going to paste in that particular URL string. And now in the closure here, we can just go ahead and grab the data. I'm going to ignore the response, and we'll just validate that the error doesn't equal nil, or error is nil, I should say. So we'll say data is data, error is nil. Otherwise, you know, something went wrong. And then finally down here, we want to decode this data into our actual entity, which is our router or VIPER pattern. So here we can go ahead and say let's response is going to basically be try JSON decoder, and we're going to go ahead and decode a collection of users from the data. And what we can do is once we have this response, we can even call them entities, so it's named a little better. Hopefully I spelled that correct, entities. And in the failure case here, we also want to notify the presenter that, hey, something screwed up, but because we don't want to just leave that hanging. We also, of course, want to not forget to execute this task by saying task.resume. And we also want to capture weak self here so we don't cause a memory leak. So in this case, I'm going to go ahead and say self. And we're going to say self.presenter, and this has two functions on it, or we have one function rather, I can say. So this function, we're going to say that this finished with a failure, and we need to pass in an error in terms of what happened. So what I could go ahead and actually do here is pass in any random error, or we can even pass in nil if we go and supply it that way. So what I'll go ahead and do is we'll come back to the presenter, the any presenter protocol definition here, and in the results I'll actually go ahead and cheat a little bit and say error optional. What you would want to do, actually it's not going to even let me do that, so let's just do it the correct way. So let's go ahead and actually declare our own errors here. We can go ahead and say enum of fetch error of type error, and we can go ahead and say case failed, I will just go ahead and use that. You probably want your own actual specific error codes to handle them more appropriately, but here we'll go ahead and say fetch error.fill to fetch, which is a terrible generic error, but that's okay. And in this case, what we can go ahead and do in the failure is we would be catching the error itself, so we can just propagate that back up. And then keep in mind, we want to handle this case as well, which is going to be the success case. And instead of passing back a failure, of course, you would pass back a success with your entities. So that is the interactor doing its interaction piece in a nutshell. Let's go to the presenter and handle this jazz. All right, so we're in the presenter, we've got this here. So what I can go ahead and do is I can say switch on the results. If we go ahead and have gotten our users, we can say on our view itself, go ahead and update with a collection of users, just like that. And the failure case, we have an error. We'll ignore the actual error itself, but I will go ahead and say users, you want to update with an error, and I'll just say something went wrong, just like that. So that'll notify our view basically. And if we jump into our view now, we want to implement those presenter delegated functions. So we have these here. So update with users, we're going to say self.users is going to be users. We want to hold an array of users here, which will be an array of user models like that, empty by default. And once we have gone ahead and done that, we also actually want to do it on the main thread. We can say self.users as users. We can also say self.tableview.reload data, just like that. And that'll update our actual table view. I will also say self.tableview is hidden is false, like that. And then down here, we're going to say number of rows will be users.count. Now let's properly dequeue a cell. So here I'll say let's cell is a table view, and we're going to dequeue a reusable cell with an identifier of cell, which is what we registered up above. For index path, I'll go ahead and return the cell here. I will say cell.textLabel.text is going to be the nth user. All right, .name. So go ahead and hit Command B and make sure everything is still building, which it looks like it is. Now let's go ahead and give this a run, and let's see if we're getting our table view of users. So we definitely see our blue background, but we're not seeing our table. So let's see what gives. I have a hunch that the API call might be failing. So let me go ahead and print out in here if the error occurs, and we'll also print here got users. Let's take a close eye, keep a close eye on our console down here. So it looks like we're not even getting to this point. So let's see what's going on with some more print statements. So we come into our presenter and we are definitely calling get users. Our API URL endpoint definitely looks correct. So let me go ahead and put a print here. We're going to say start fetching. You could alternatively also use breakpoints, of course, but we'll go ahead and use this down here. So we're not even calling this. So let me go ahead and see where we called get users, and let's see what the heck is going on there. The reason actually we're not doing this is because by the time we actually instantiate the presenter before this interactor is actually set. So you actually have two things you can do on this. You can actually do a did set and call it directly in here. So basically once an instance of the interactor is set, or if you hit Command-Shift-O, you can jump to any file, you can go back to any router, you can actually call it on the interactor after the interactor has been created. So you can actually call it here as well. However, this isn't great practice because it's not the router's job to kick off interactions. It is the presenter's job, however. So I'll stick to doing it in the did set here. So go ahead and give it a run once more. And let's see if we get stuff now. All right, so there is our list of users looking really good. So you can see it's actually super fast where you can't even really tell, that we're getting stuff back. It does flash for a half second, but that's the VIPER pattern in a nutshell. So one place that I cut a corner that we can wrap up and clean up rather really quickly is in our view, we didn't actually implement this update with an error. So what I'll go ahead and do in here is perhaps we want to show maybe a label in the middle of the screen saying, you know, something went wrong. So let me just go ahead and create a basic UI label here. And in here, we're going to go ahead and say UI label, return label. I'm going to say label.text alignment will be centered, and label.isHidden. This will also be hidden by default. The presenter's functions will basically figure out, you know, which thing we want to actually present and show. And we'll go ahead and say add subview for the label. Label.center is view.center. And we should probably do this in the layout function down here. We'll also give the label a frame of cgrect 0, 0, 200, and perhaps 50, kind of arbitrary numbers there. And in this function here, once again, we're going to dispatch onto the main thread since the caller comes from a background thread. We'll go ahead and say that users is going to be empty in this case. We're going to go ahead and make sure the table view is hidden in case it was unhidden at some point, or shown, I should say. And we'll go ahead and say that the label hidden will be false. So I'm just going to go ahead and screw up the response purposely in the entity so it does actually go ahead and fail. So we'll also say, this name has, you know, some malformed characters. We'll add 3 S's there. And if we go ahead and give this a run, and let's see, we have an error here. Let's see what got screwed up. All right, we're saying cell, text label, users, because this doesn't exist anymore. We'll go ahead and change that. We should see that an error comes back, and we want to see a label in the middle of our UI. So let's see what's going on. We've got start fetching, and we should be coming to this function here. So let me go ahead and print out error to see if we're coming into there. So we definitely are. Something went wrong is definitely printing. The one silly thing that I forgot to do is actually assign the text to the label. So we'll go ahead and say label.text equals your error itself, and then we'll actually see it on the screen just like that. So there's VIPER in a nutshell. So before I forget and push this code up, let me go ahead and actually fix up that typo that we did intentionally. Let's do a quick recap because I think I went through this a little quickly. So VIPER, of course, stands for View, Interactor, Presenter, Entity, and Routing. Let's start at the bottom up. So the router is the entry point where your entire flow for a module comes in. Think of a module as a logical, part of your application. If you have a tabbed app is one tab and everything you route sub of that. The router holds on to the entry points, and it also is responsible for creating the interactor, presenter, and the view and all that good stuff. The router is often called from, another router. You could have one router call another, or when your app launches in scene delegate here, we use the router. The next thing that we got is the entity, which is nothing more than the model. It's just an unnecessarily fancy term for a model. It's all the entities that make up your data in your app. Kind of dumb if you ask me in terms of naming. Your presenter is the most cohesive glue in your application. It holds a reference to your router, to your interactor, and to your view. You might be wondering, why does it hold a reference to your router? And the answer is, if you wanted to route to another sub router or something else, you could also extend this any router to say, go ahead and stop this current router, or go ahead and route to a destination. It's a little subjective of how advanced you want your router to be, but that's why the presenter here holds on to it. The presenter, once the interactor is set on it, is responsible to go ahead and tell the interactor to go ahead and perform an interaction. And once the interactor comes back in with data, it'll go ahead and call the presenter, and the presenter will tell the view to go ahead and update, hence being the presenter, which brings us to the view here. So the view can also be a controller, so not to confuse it with just a simple UI view. And it too has functions on it that the presenter calls, and the view also holds on to the presenter. You might be wondering why. So for example, if you tap on a button on your view and you want to show a UI alert controller, aka like a pop-up alert, you wouldn't really want to do that here. You would want to tell the presenter, hey, go ahead and present this alert. And let's see, last up, we've got the interactor, which a lot of people will call the backbone of your application. It performs all the core interactions. So if you think of an app like Instagram, the interactor would be responsible for going and uploading a post, or, fetching new posts for the feed and things like that. So it's basically, the spine of your application. And without the interactor going and interacting and setting up entities, aka models for you, there would be nothing to present. So the interactor holds onto the presenter and performs core interactions such as this API call. So that's all I've got for you guys today. This has been something that's been requested for a while. It's a little bit of an advanced pattern, so I wanted to try to structure this video to be as helpful and useful as possible. Let me know in the comments down below, do you think this pattern is useful? Is it overkill? I don't know, I'm pretty indifferent on it. Definitely don't forget to drop a like down below if you haven't done so already, and subscribe to the channel for iOS, Swift, and Swift UI videos. Thanks again for watching. I'll see y'all in the next one.